as you can see here, according to the National Council of Teachers of Mathematics, one of the content standards is it is absolutely essential that students develop a solid understanding of the base 10 numeration system and place value concept by the end of grade 2. Grade 2. Kids learning mathematics must have a solid understanding of the base 10 numeration system, okay? By end of grade 2. So that's early. So they have to understand this positional value. And so we are going to talk about base 10 numeration system now as we go into the final, really the final talk about different numeration systems with the Hindu Arabic numeration system. The Hindu Arabic numeration system. That's what we use now. That's what most of the world uses now. It is called a positional numeration system, and it was named for the Hindus. They invented it, but the Arabs really transmitted it to Europe. It's base 10. Base 10. And it's the place value is determined by the position, just like we saw with the Mayans, the Babylonians. The position matters, and we have 10 digits, right? It's 10, base 10, and we have 10 digits. 10 digits that we know and love, these, right? So every single number that we want to represent can be done so using those 10 digits and their position in the number. Think back to some of the other systems that we've looked at, right? The Mayans, they had only a couple different symbols, lines and dots, but it was really how they arranged them. And then they had their positions. The Babylonians only used 2 symbols, but again, they would combine more symbols together, and then the positions matter. So now we've got 9 symbols, 9 different digits, and it's all about position. We're not repeating digits anymore, right? We're not using a system of tallying anymore. We just have those 9 different digits. And so you all know and love our place value system, right? So in this number that you see here, 75,063, we have over on the right-hand side is sometimes we'll call it our ones place, but it's that units, right? Then we go to the tens digit, that would be that 6. The hundreds digit is here. The thousands digit is the 5, and the 10,000s digit is the 7. And we could keep going and going. So notice how that starts to link with what we already have learned, right? So the ones place, you got this 3 that exists here. Well, that 3 has a value of 3 times whatever place it's in, right? The ones place means it's equal to 3 times 1. The 6 is in the tens place. So we multiply 6 times 10 because it's in the tens place. This 0 is in the hundreds place. Or notice that because it's the 6 is in the tens place, that's worth 10. The hundreds is 10 to the second. Thousands is 10 to the third. 10,000s is 10 to the fourth. There's that idea of base 10. We have 0 times 100 there. Again, there's that 0 that we use to say, hey, we don't have anything in this column. This 5 is really worth 5 times 1,000 because of where it exists in the number. And that 7 in the 10,000s place is worth 7 times 10,000, right? So we find each of those values, we add them all together, and it gives us this, right? It gives us that one singular number. So the condensed form of the number is what we see here, right? 7,000 or 75,063. That's the condensed form. when we write it in this form with all of these things multiplied out, all of these things multiplied out like that, shown as an addition problem, or you can even write it with exponents at 7 times 10 to the fourth for this one, plus 5 times 10 to the third, plus 0 times 10 to the second, plus 6 times 10, plus 3 times 1. This notation here, this is called expanded form. Expanded form. Right? So we can either use it, do expanded form using the actual values of the bases, or we can use the exponential version of the bases. But those can be useful, especially when young learners are trying to make sense of this. And we're going to see how we use expanded form in another way in a little while. So one last thing is, again, we talked about this idea of positional numeration systems. That's different from, remember the additive numeration systems that we learned about, like the Roman numerals, and we also talked about the Roman numerals, and what was the very first one? The very first one we introduced, I don't even remember. Oh, the Egyptian, right? Egyptian and Roman were additive positional numeration systems. You can see the official definition here, right? A number is selected for the base, 10 in this case, and up to 1 less than the base, right? And so if you're base 10, your the symbols that you use go up to 9. If you were going to work in something like base 5, you would only use the numerals 0, 1, 2, 3, and 4. Whole numbers are represented in a positional numeration system by writing one or more basic symbols, our numerals, side by side with their positions indicating increased power of the base, right? So we have the ones position, the tens position, the hundreds position, the thousands position, right? It's kind of like each one has its own little column. So that's the definition of a positional numeration system. So just to make sure we do understand this, if I write a number like this, and I highlight one of the numerals like this right there, what is the value of that numeral? What is the value of that 7 that's right there? So go ahead and think about that. Hopefully what you noted is that that 7 has a value of 70,000. It's in the 10,000th place, so its value is 70,000. What about this? What's the value of that 8 right there? Hopefully you said that 8 has a value of 80 because it's in the tens place, and 8 times 10 is 80. So it's really crucial that we understand the value of the numbers based on the position that they have in the number. So a couple other notes about reading and writing numbers. In English, right, our language, the numbers from 1 to 20 are all single words, right? Think through them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right? So we've got 20 different words for those first 20 numbers. Once we get to 21 through 99, then with the exception of multiples of 10, like 30, 40, 50, they're all compound number names, and they are hyphenated, right? Hyphenated, if you're going to write these properly. So what does that mean? If we want to write this number in words, we would say 23. That is the proper way to write the number 23 with a hyphen. Any number from 21 to 99, with the exception of 20, 30, 40, 50, 60, they're all going to be hyphenated. Okay, that's even true if we go past 99. So how would you say or write that number properly using words? Go ahead and pause and try it. We would write that as 347. And notice that the 47 is hyphenated. Okay. Once we get to more than 3 digits, once we get to more than these first 3 digits, then beyond that, they're read by naming each group of 3 digits, which are called the periods of the digits. So periods, when we start to write our numbers, are really in groups of 3. Groups of 3. And within each period, the digits are read the way we would read any number from 1 to 999, and then the name of the period, okay? And so we could take a couple examples of this. So if I wrote, in fact, let me give a sort of a big number that shows some of what those periods are. So we can see here the 319, that's just regular 319. Those are those first 3 digits. Once we go to the next 3 numbers, now we're in the 1000 period. So any of these digits here would be read with the word 1000 after it. Then we bump into the next period, which are millions, grouped in 3s. Then we have billions, again, grouped in 3s. And then we have trillions, which are also grouped in 3s. Here we only show 2 of them. Okay, so the way you would read this entire number is 23 trillion 478 billion, the name of the period, 506 million 42,000, don't say the 0, 319, right? That's how we use, or that's how we say big numbers like that. One other one, just to kind of check this out. What if I wrote this? No, sorry. This. So how would you say that number appropriately? Go ahead and give it a shot. So this is the million period. This is the 1000. So we would say this number 1,413,091. That's how we would say that. Did you notice, this is a pet peeve of mine. Did you notice I never said the word and, did I? So many people use this incorrectly. Again, it's a pet peeve of mine. Often people will say the word and before the 1 through 99 part, right? So some people will read this number right here as 517, but there is no and there. It should just be read 517. So don't say and. The only place you say the word and is once you introduce a decimal and numbers after that decimal. That decimal is read as the word and, but you don't actually have the word and when you're reading a whole number. All right. Lastly, in this video, we just need to talk about rounding numbers. So let's talk about rounding numbers. Rounding numbers basically is sort of saying it's close enough, right? And it really depends on the situation that we are in, how we want to round, and where we want to round. And there are a couple different ways that you can choose to round a number. Let's say we want to round this number, 1, 3, 1, 2, 5, 7, 3, 2, 8. So first of all, how do you say that number? Pause and try to do that on your own. 131,257,328. Okay. And let's say we run around this to the nearest million. Now, again, there are a couple of different ways you can do this. One way, and again, you're trying to think about how might you teach this to younger learners. You could say, all right, well, the million place is right here. So what you can do is write below it and above it the nearest million, 131 million, and then all these would be zeros. Or above it is 132 million, and all these would be zeros. So these would be the millions above and below 131 million. And really your job is then to say, well, which one's closer? Or which one is it closer to? And hopefully you'll see that this is closer to 131 million. And often we can tell by what that very next place value is, that next digit in the 100,000th place, because this is 2, well, we're less than halfway to 132 million. The more familiar approach to rounding is with a set of rules. And here's what your established rules might look like if you're rounding for whole numbers. Locate the digit with the place value to which the number is to be rounded. That's the first step. So we're going to round to the nearest million. And then check the digits to its right. So the first digit to the right is a 2. If the digit to the right, this one, is 5 or greater, then each digit to the right is replaced by 0, zeros, and the digit with the given place value is increased by 1. So if this number here had been 5 or larger, then we would have bumped that up to a 2. If the digit to the right, this one, is 4 or less, which is what we have in this situation, each digit to the right is replaced by 0, and that's it. So we're basically rounding it to 131 million. So those are our rounding rules. So just, again, a little check to test your own rounding skill. We're going to take the same digit, or the same number, 131,257,328. I said the word and, I don't say the word and, 328. And we'll check 2. What I want you to do is round it to the nearest 10,000, and then round it to the nearest 1,000. So go ahead and pause the video and do both of those roundings for me. So we'll start with the nearest 10,000. So the nearest 10,000, I'm going to rewrite the number 131257328. So where's the nearest 10,000? It's here, or the 10,000th place is the 5. So I'm going to look to the number to the right. It's 5 or bigger. So I'm going to change all of these numbers to a 0, and I'm going to increase this 5 by 1. 131,260,000. 131,260,000. What if we want to round to the nearest 1,000? The nearest 1,000. 131,257,328. So the nearest 1,000 is here. The number to the right is this 3. So these all become zeros. Because this was less than 5, I'm just going to keep the 7 as it is. 131,257,000. 131,257,000. And that is it. So as we move forward, the next video, we will talk a little bit about different models that we use for numeration.